In the last video, we talked about the antiderivative, and now we're going to introduce some notation and a different term for it. So if we have our lowercase f of x is a function whose antiderivatives are capital F of x plus c, the usual way to express this is using, it's called an indefinite integral. So this symbol here is called the integral symbol. It's indefinite integral. It's like a stretched out S. And then here is where we have the derivative. And then we have this dx. This dx tells us what we're integrating with respect to. So it's always a d, and then this variable always matches whatever the variable is in the function. And it's very important that you always put dx. Students always leave it out. But if you ever run into Calc 2 or 3 or other higher level math, this is really important because they'll have functions of multiple variables, and you have to know which variable you're integrating with respect to. In this class, we're just going to do one, so it's more of just proper notation to include it. So then when we take this symbol, the integral, it means we're taking the antiderivative. So it means we're finding what is the original function. And again, we put plus c for the constant. So this symbol is called the integral sign. Anytime you write the integral sign, you put whatever you're finding the antiderivative, so the original derivative here, and you always put dx, or if it's in terms of y, dy behind it, and then equals, and then whatever. So this is, again, the derivative. And if I just write it with the notation of lowercase f, f prime, and then this is my original function, and we always put plus c. So it is called the indefinite integral. F of x, what your derivative is called the integrand. And from now on, we are going to use this notation. So how we would write it for a problem we've done is the integral of 2x dx. So the derivative is 2x. So f of x would equal 2x, that lowercase f of x. If I take the antiderivative of that, I get x squared. And then again, I always put that plus c. Dx tells me the variable of integration is x, so I'm integrating like with respect to x. And if the capital F prime of x is equal to this lowercase, then we know that f of x is this side equals x plus c, x squared plus c. So again, this is my antiderivative, and the 2x is my derivative. So again, we can use that power rule to find it. So how they're going to write it now is with this integral sign in front of it, and then x to the n dx. Again, n cannot be -1. But if we're taking the integral or the antiderivative of that, we use that same rule we talked about in the video before, where we add 1 to the exponent, divide by that new exponent, and then put plus c. So for example, like x to the 5th dx, that would be x, we would add 1. So 5 plus 1 is 6. I divide by that new exponent of 6, and then I put plus c. And again, this is the notation we're going to use more than like labeling one as f prime and the other one as f. So just for 2 more problems that are a little bit harder, I want the integral of the square root of x dx. So again, this is my derivative, and I am trying to figure out what is the original. When you're doing the square root of x, we need to make it x to the 1/2, just like we did for derivatives, and then we're going to use that rule. So we just write equals and then put the answer. We don't keep the integral sign once we actually take the antiderivative because we already did the operation. So again, for this, we add 1 to the exponent, and then we divide by that new exponent. And don't forget your plus c. So this would equal x 1/2 plus 1 is 3/2 over 3/2 plus c. And then if you remember from when you learned fractions, if you divide by a fraction, that's the same thing as multiplying by the reciprocal. The reciprocal is flipping the fraction. So this is the same thing as 2/3 x to the 3/2 plus c. That's how we do the square root. Same thing, if we have x to a power in the denominator, we need to get that out of the denominator. So what we can do is we can make that x to the -3rd, and then we can use our power rule. Right? You can't use the power rule just in the denominator. It has to be in that format of x to the n. So you have to move it to the numerator. And again, you use that same rule. So you add 1 to the exponent, and then divide by that new exponent and put your plus c. So that would give me x to the -2nd over -2. And if I were to simplify that, I would move the x to x to the -2 in the denominator and make it x squared. And then that means there's a 1 on top. So that's a few examples using that new notation and finding the antiderivative or indefinite integral using the power rule.